This video is about what we call a difference of squares. So notice it's called difference of squares, which means to factor these binomials, it must be subtraction. There is no such thing as a sum of squares, just a difference. Now, it's called difference of squares because you should have a perfect square minus a perfect square. If you do, these are one-step factoring problems. So these are really easy if you can recognize your perfect squares. A perfect square is a number that you can take the square root of, and the result is a whole number. So the first example I have on here is x squared minus 16. The square root of x squared is just x, because x times x is x squared. The square root of 16 is 4, because 4 times 4 is 16. So this factored is x plus 4, x minus 4, and I am done. So the setup for a difference of squares is you have to have opposite signs, and in the first spot of the parentheses, you're putting the square root of the first term in the binomial. And then the second spot in each parentheses, you're going to put the square root of the second term in your binomial. So I'll show you another one. It's the same pattern. I recognize 100 as a perfect square. The square root of 100 is 10. And I'm done. So when you have the difference of squares, it doesn't matter if you put the plus first or the minus first, as long as they have opposite signs. So x squared minus 100 is just x plus 10, x minus 10, or I wrote it with the sign switched. It really doesn't matter. The last one is also a difference of squares, 9x squared minus 4. You need to recognize that 9 is a perfect square and 4 is a perfect square. And since x is being raised to an even power, we're good. So the square root of 9x squared would be 3x. That goes in our first spot. The square root of 4 is 2. That goes in our second spot. And then you always have to fill in opposite signs, and we're done.